What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the intermediate system to intermediate system routing protocol is. So let's get into it. Let's have a little chat about one of the lesser known but incredibly powerful routing protocols in the networking world. That is the intermediate system to intermediate system routing protocol, better known as ISIS. Now, if you've been around the networking block, you've probably heard a lot more about OSPF or even EIGRP, but ISIS, well, that one tends to fly under the radar, especially in enterprise environments. However, when it comes to large-scale service provider networks or extremely scalable, stable systems, ISIS is often the secret sauce behind the scenes. So let me go ahead and break down this protocol. We're going to explore what makes it special and understand why it still plays a major role in modern networks, even in the age of software-defined networking and automation. All right, so exactly what is ISIS? Well, at its core, this is a linked state routing protocol, just like OSPF. That means it builds a complete picture of the network topology using information shared by its peers, and then it uses an algorithm to compute the shortest path to each destination. But here's where things get interesting. This protocol wasn't originally designed for IP. ISIS was created in the 1980s by the ISO for use with a protocol suite called CLNS, or Connectionless Network Service. So think of CLNS like a sibling of IP, except that it never really took off. But the networking world saw value in ISIS, especially its scalability and efficiency. So instead of throwing it away, we extended it to support IP routing. And that's why you'll often hear it referred to as integrated ISIS, because it integrates support for both CLNS and IP. All right, so let's go over some similarities and key differences between ISIS and OSPF. So at first glance, ISIS and OSPF seem pretty similar. Both are interior gateway protocols, both use the shortest path first algorithm, and both rely on link state advertisements to build up a network map. But if we dig a little deeper, then the differences start to shine. And the first difference is encapsulation. So OSPF runs directly on top of IP using protocol number 89. ISIS, on the other hand, it does not use IP at all for transport. Instead, it runs directly over layer 2. That means it doesn't require an IP address to function on an interface. And this makes ISIS more flexible in environments where IP may not be configured yet. It also means that ISIS is less susceptible to IP layer attacks since it doesn't rely on IP to operate. Another key difference is network hierarchy. So OSPF has a strict hierarchy with areas and its backbone. ISIS uses a two-level system. You have level 1 for intra-area routing and level 2 for inter-area routing. So think of it like level 1, this is basically your domain, and level 2, this is traffic between your domains. And routers, they could be level 1 like an OSPF area router. They can be level 2 like an OSPF backbone router, or they can be both like an ABR in OSPF. And then when it comes to protocol design, OSPF was designed with IP in mind, and ISIS was designed as a general routing protocol and later adapted for IP, which makes it easier to extend to new protocols like IP version 6. And also, OSPF needed an entirely new version, such as OSPF version 3 for IP version 6. But when it comes to ISIS, it just got a simple extension. And if you're lost or confused about what I'm talking about when it comes to OSPF and EIGRP, just go click on my playlist and click on Internet Routing Protocols and check out the lessons that I posted up in there, where I'm specifically talking about routing protocols like EIGRP and OSPF. All right, so let's talk about how ISIS actually works. So here's a step-by-step breakdown of how this whole thing goes. So step 1 is it's going to discover neighbors. So routers, they send out these things called hello packets, and they're called ISIS hello PDUs, or protocol data units, to discover neighbors on each link. And these PDUs are sent directly over the data link layer, so there is no IP that's required. In step 2, they build what are called adjacencies. So once two routers see each other's hello PDUs and agree on parameters like a system ID and area, they form an adjacency. And there are different types of adjacencies based on levels, like level 1 or level 2. And routers, they will only form adjacencies if they operate at compatible levels. Then step 3, they exchange link state information. So each router builds a link state database by exchanging LSPs or your link state PDUs with its neighbors. And these LSPs contain information about connected interfaces, metrics, and neighboring routers. And this information floods throughout the network, allowing each router to see the full topology. And then there's step 4 where they calculate the best paths. So once each router has a complete view of the network, it runs the SPF algorithm to compute the shortest path to each destination. And the result? Well, you're going to get a routing table that tells the router exactly where to send packets. All right, so next, let's go ahead and talk about some of the major building blocks of ISIS. And the first key component is the system ID. So every router in ISIS has a unique system ID, and this is usually based on a loopback address or MAC address, and it's 6 bytes long and identifies the router within an area. Then you have what is called the NET, or the network entity title. So you could think of this like a combination of an area and a router ID. And it looks like this long number right here on your screen right here with a 49.0001. That'll be the area ID. The middle portion is the system ID. And the last 2 zeros are going to identify the incel or the selector, which is usually 00 for routing. And then you have the IS types. So you got level 1 IS. So you could think of intra area, and this only knows routes within its area. You got level 2 IS. So think of inter area, and this connects different areas. And then you got level 1 through level 2 IS, and this participates in both and redistributes routes between levels. And then we have what are called PDUs. So there are several types of PDUs in ISIS. You got your Hello PDU, and this is used to discover and maintain neighbors. You got your LSPs. They advertise link state information. You have your CSNPs, or your complete sequence number PDUs, and they provide a summary of all LSPs known to the router. You have what are called PSNPs, or partial sequence number PDUs, and these are used to request missing LSPs. All right, next let's talk about why ISIS is a favorite among service providers. So most enterprises do not run ISIS. Instead, they go with OSPF. ISIS is extremely popular in large-scale service provider networks, and the reasons is because of scalability. So ISIS, it can handle extremely large topologies with ease. Its flat area design and flexibility with hierarchical routing make it great for big networks. It provides stability. Because it runs at layer 2, ISIS is not as exposed to IP layer instability or spoofing attacks, and it also tends to recover from network changes smoothly. Another benefit is extensibility. So if you want support for IP version 6, you can just add a TLV, or a type length value, for IP version 6. And ISIS is built with TLVs, which make it easy to extend and evolve. OSPF, by contrast, this often requires major protocol overhauls for new features. And then ISIS is vendor neutral, so it is supported by all the major networking vendors like Cisco, Juniper, Nokia, and others. And basically, it's a standard and not a proprietary protocol. All right, next let's talk about ISIS metrics and path selection. So ISIS, it uses a 6-bit metric field by default, which supports values from 0 to 63. But in most modern deployments, we use what are called wide metrics, which supports much larger values up to 16 million plus. And this allows for more granular path selection based on bandwidth, delay, or other factors. There are no default metric values based on bandwidth like in OSPF. Instead, you must manually configure interface metrics, and the SPF algorithm then uses these metrics to select the best path. All right, next let's quickly talk about ISIS for IP version 6. So one of the coolest things about ISIS is how it handles multiple protocol families. So you don't need a new version of ISIS to support IP version 6. Instead, you just need new TLVs, or type length values, to carry IP version 6 information alongside IP version 4. And basically, this means you can carry both IP version 4 and IP version 6 routes in the same protocol instance, which makes it super convenient for dual stack environments. All right, so when it comes to modern networking, is ISIS still relevant? Well, of course it is. Even in the age of EVPNs and VXLANs and SDN controllers, ISIS continues to provide a rock-solid foundation for underlay routing, and many data centers are embracing ISIS for leaf spine architectures because it's simple, it doesn't require IPO interfaces, and it scales very well. Plus, its TLV structure makes it easy to integrate with modern technologies and services. Now, with all of that being said, No protocol is perfect, and ISIS does have its downsides. The first downside is there is a steeper learning curve. Because it wasn't designed for IP and uses unfamiliar terminology, ISIS can be intimidating to network engineers who are used to OSPF or EIGRP. It also has limited enterprise adoption. So most enterprise engineers have never touched ISIS, so the talent pool is smaller, and that can make staffing or training more challenging. And then there's sparse documentation. So there's not as much vendor documentation or community support compared to OSPF. But once you get the hang of it, then ISIS is essentially a dream to work with. Now, here's a quick example of an ISIS configuration on a Cisco device. As you can see, the router identifies ISIS, it identifies the net information, it identifies the gigaport, the IP address, and all this other relevant stuff that you need to make all of this happen. And basically, it's really that simple. You essentially just define the net, assign the interfaces, and then you're off to the races. Now, let me go ahead and wrap all this up. So, even if you're not working for a service provider, understanding ISIS does give you a deeper perspective on how routing works beyond just IP. It sharpens your knowledge of layer 2 to layer 3 transitions and forces you to think about network architecture in a new way. Plus, if you're aiming for roles in large networks, data centers, or cloud scale operations, then ISIS might be the routing protocol that defines your future. So, don't just let the name scare you off. Intermediate system to intermediate system. This might sound like a mouthful, and it is. But once you get past the acronym, what you'll find is a clean, powerful, and elegant protocol that's more relevant today than ever.